Alrighty, so if you are on this video, this is video number 3. That means you've watched my introduction video or good morning video, and then you've also watched the short 4-minute video on what we're learning in probability. So now here we are going to be working in the book, which means it said on the agenda, page 711. And so I said, make sure you have your book and a calculator and a pencil ready. So if you don't have that ready to go, pause the video, get your supplies ready, and then we will begin again. So here we go. Vocabulary startup. We're going to look on page 711 for lesson 1, and we're going to go through this first page a little bit and talk about some vocabulary and also just look at some examples in the real world where we would use probability. And actually, this whole chapter, you'll see a lot of real world connections. So starting at the top here, probability is the chance that some event will occur. And a simple event, specifically for this lesson, lesson 1, is one outcome or a collection of outcomes. Well, what's an outcome? What does that mean? So when you look at the box, the math definition for an outcome is a possible result in a probability experiment. Makes sense, right? And then if we think about in the real world, how can you put that in your own words? What does that mean? I just think about it's the way something turns out. And it could be anything, right? An outcome is just the way something turns out. All right, let's look below that. For a sledding trip, you randomly select one of 4 hats shown. And so complete the table to show the possible outcomes. So you see on the right-hand side, there are 4 different colored hats. And so outcome number 1, it's very possible you could select a green hat to wear that day. Outcome number 2, you could select a blue hat because there's a blue hat over in that grouping there. Outcome number 3, you could pick the purple hat. And the last outcome that's possible, outcome number 4, you could pick that red hat. So you have 4 choices, 4 possibilities of different colored hats that you could pick. So number 1 says, write a ratio that compares the number of blue hats to the total number of hats. Well, there's 4 hats over here in this group. And the number of blue hats, there's only 1. So it says write it as a ratio. So you can write a ratio a couple different ways. You can write it like this, 1 to 4, 1 blue hat to 4 total hats. Or you could write it as a fraction, 1 over 4. Again, still representing 1 blue hat out of 4 total possible. And then number 2, describe a hat display in which you would have a better chance of selecting a red hat. Well, right now, when you select a red hat, it's the same thing as in number 1, as we looked at right now a few minutes ago with the blue hat. You have 1 red hat out of 4 possible. So 1 out of 4, and really, I should probably put this as a percent as well. That's 25%, right? So you had a 25% chance of pulling a blue hat. Same percentage for a red hat. So you have a 25% chance of getting a red hat as well. Well, you want to make it a better chance of selecting a red hat. So what's something we can do to this grouping that's here? Well, we could add another red hat. We could put 2 in there. We could also put 3 hats total, red hats, excuse me. So we could add 2 more red, which would give you 3. So let's try that. If we add 2 more red hats, that means we would have 3 red, right? And if I write this as a ratio, so I'm going to put it in fraction form. If I add 2 more red, that means I no longer have 4 total hats. I have 6 total hats. So I would have 3 red out of 6 total now, because I'm going to add these 2 more red hats to my display. And if you think about 3 out of 6, that's the same thing as saying 1/2, which is also saying that's 50%. 3 hats out of 6, 3 red hats out of 6 total hats would give you a 50% chance of picking a red hat. So it says, just describe a hat display. So I just showed you this one. You could have talked about just adding 1 more red hat. That's fine. Then you would have had 2 out of 5. You could have talked about adding 3 more red hats, which would have given you 4 out of 6, and so on. So you can, there's no right or wrong here. You could have just added as many as you wanted to just show you have a better chance of getting that red hat when you select it. Okay, let's keep going. So let's start to look at probability, the definition for it on page 712. So in words, it says at the top, the probability of an event is a ratio that compares the number of favorable outcomes to the number of possible outcomes. And so you see that fraction there, or the ratio, we can call it, number of favorable outcomes in the numerator, number of possible outcomes in the denominator. So underneath here, it says, we've got this almost like a number line essentially, and it talks about the probability of a chance event is a number between 0 and 1 that expresses the likelihood of an event occurring. Greater numbers indicate greater likelihood. A probability near 0 indicates an unlikely event. A probability around 1/2 indicates that the event is neither likely or unlikely nor likely. And a probability near 1 indicates it's a likely event. Probability can be written as a fraction, decimal, or percent. So if you look at this number line at 0, that's 0%, and that's considered impossible. Well, what are some examples that we could use where we would know that a probability of something occurring would be impossible? So I'll give an example over here in the green section here. Impossible. So 0% chance, right? Can I walk to the moon? Can you walk to the moon? No. That has a 0% chance of happening. Okay, that's impossible. You can't just walk to the moon, right? So with probability, that's a 0% chance. Like I said, it's called an impossible event that can occur. Now, if we talk about, I'm going to go all the way to the right. I'm going to talk about something that's certain. So at 1 or 100%, 100% certain to occur. So I'll give you an example over here. So for something to be certain means it's going to happen 100% of the time. My example would be, so out of 100%, right? 100% certain it's going to happen. The sun, rises in the east and sets in the west. That's always going to happen. That's 100% probability, certain, 100% certain that the sun will rise in the east every day and set in the west every day. Okay, so we've talked about one example of a 0% impossible probability, and we've talked about one example of 100% certain probability. And then you've got this in between, okay? So anything from 0% to 50% is unlikely to happen, unlikely for that probability to occur. When you get to 50%, like it says likely to happen as not. Okay, you have a good chance, but you also don't have a good chance. So, halfway, right? Equally likely. And then anywhere from 50% to 100%, you're more likely that probability is going to occur. So when we start to look at some examples today, I'm going to say to you, is this going to be something that's going to be impossible? Will this probability be impossible? Will it be unlikely? Will it be equally likely? Will it be likely, or will it be certain? So this number line from 0 to 1, we absolutely will refer back to this. And just like it said, we're going to be able to express as fractions, decimals, and percents. Okay, so let's take a look at example 1 here. It says there are 6 equally likely outcomes if a number cube with sides labeled 1 through 6 is rolled. So in the book, they call dice or one die a number cube. So just think about it in that terms, right? And on a number cube, on a die, there are 6 sides and there are 6 numbers. And so what's the probability of getting a 6 or rolling a 6 on the number cube? Well, there's only 1 6 on the number cube. So the number of favorable outcomes is 1 in the numerator. And the number of possible outcomes, meaning how many total numbers do you have on that number cube? Well, there's 6 possible outcomes. So 1 out of 6. The probability of rolling a 6 is 1/6, or about 17%, or about 0.17, 17 hundredths. And so this is where the calculator comes in, right? As we start to do some examples, this 17% is coming in by doing 1 divided by 6 on your calculator. 1/6 is the same thing as 17%, and as a decimal, 17 hundredths. So this would be considered at 17%. I scroll back up to this number line. That is considered an unlikely probability. This is unlikely that you will roll a 6 on the number cube. It's unlikely. It happens, right? Some people get lucky and get that number. I know when I'm playing games and I have to use die, I have a hard time getting 6s. And so now you can actually look at the probability of it happening. It's 1 out of 6 chances, right? So unfortunately, it's unlikely to occur. Now look at your got it. Do this this problem to find out if a coin is tossed, right? Find the probability of the coin landing on heads. Write your answer as a fraction, percent, and decimal. Okay, so finding the probability of the coin landing on heads. Well, there's only one possibility of getting heads on the coin. And remember, that goes in your numerator. And in the denominator, oops, that is messy. Let me try that again. One probability of getting heads. Okay. Denominator, how many possible outcomes? Well, there's 2 possible outcomes on there, right? Heads or tails. So the probability of when you toss the coin, you getting heads is 1 out of 2, 1/2, which is the same thing as 50%, which is also the same thing as a decimal, 50 hundredths, 0.50. And so at 50%, for you to flip the coin and get heads, that's as likely to happen as not. As likely to happen as not, which means you have a good chance of getting it, but you also have another, the opposite of that, of not getting it. So half and half, right? Okay, let's keep going and look at number 2. Example number 2. Find the probability of rolling a 2, 3, or 4 on a number cube. So the word or indicates that the number of favorable outcomes needs to include the numbers 2, 3, and 4. So the number of favorable outcomes, we could roll a 2, we could roll a 3, or a 4, which means that's 3 possible favorable outcomes there. And remember, we're talking about a number cube. We're talking about a die. So there's 6 total outcomes possible. So 3 out of 6, which is the same thing as 1/2. So the probability of rolling a 2, 3, or 4 is 1/2, 50%, or 0.5. So again, that falls on that number line right smack dab in the middle. It's as likely to happen as it is to not happen. So let's try the got it. The spinner at the right is spun once. Find the probability of each event. Write each answer as a fraction, percent, and decimal. So you're going to see letter B. So find the probability of spinning that and getting an F. So if you look at the spinner, it's starting with A and it's labeled through J. There's only one F on that spinner. So 1 out of. Now you have to think about how many spots are on the spinner. So count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 possible spots that spinner could land on, but the probability of getting an F is 1 out of 10. So now use your calculator. Okay. If you use your calculator, so I'm actually going to come over to the right on the green lined paper side here. Do 1 divided by 10. And if you do, right, 1 divided by 10, you should see 0.1, which, right, we also have to do it as a decimal. So on your calculator, you can take the 0.1 and multiply it by 100, or move the decimal 2 places to the right, which would make this 10%. So you have a 10% chance of landing on an F on this particular spinner, which makes that unlikely. That probability is unlikely to occur. Letter C, the probability of getting a D or a G. Well, I look at the spinner, there's 1 D, there's 1 G. That means there are 2 possibilities out of 10 total. 2 out of 10. And again, use your calculator and do 2 divided by 10. Now, 2/10 is also the same thing as 1/5. And when you divide that out, you would see 0.2. And make sure you're checking that. Even though I'm telling you it's 0.2, make sure you are calculating 1 divided by 5 or 2 divided by 10. And if I move my decimal 2 places to the right, that means that's a 20% chance of landing on either the D or the G when I spin that spinner. Now, this is also at 20% unlikely to occur. That's an unlikely probability for it to land on a D or a G. Letter D, the probability of getting a vowel. So think about your vowels. A, E, I, O, U. And so look to see how many of those are on this spinner here. There's the A, there's E, and there's I. So there is 3 out of the 10. 3 possible spots on the spinner out of the 10 total. And so divide that out. What's 3 out of 10 as a decimal? 0.3. And now move it 2 places to the right, or again, in your calculator at this point, you could do times 100, 0.3 times 100, and that would show you 30%. Just by multiplying by 100 on your calculator, it just moves the decimal for you. So you have a 30% chance of landing on a vowel on that spinner, which again is considered unlikely. It's below 50%, and anything from 0 to 50% is unlikely to occur. Okay, so we're going to try some more of these. We're going to go and turn to the guided practice, which is going to be on page 714. And we're going to look at the tiles over here with 1, 2, and 3. So it says a letter tile is chosen randomly. Find the probability of each event. Write each answer again as a fraction, percent, and a decimal. So the probability of getting a D. So I look over here and on my tiles and I see 1D over there. 1 out of. We'll count how many tiles you have because you got to have the total possible outcomes in the denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 tiles there. Okay. Go ahead and again divide that out. Do 1 divided by 9. And when you do, this time you're going to see 0.1 again, but it's repeating. So that 1 keeps repeating. So now if I'm going to write that as a percentage, right, I can move the decimal 2 places to the right. It's 11% if I just round it. Okay, 11% chance of getting a D tile out of that group, which again is considered unlikely. Number 2, the probability of getting an S, a V, or an L. Okay, so there's one S, there's one V, and there's one L there. So 3 out of 9. And 3 out of 9, if I simplify that, that's the same thing as 1/3. And if you know anything about 1/3, if this is a fraction you've seen often, you'll know that this is another repeating decimal. So you can do 1 divided by 3. I'm hoping you know 1/3 is 0.3 repeating. And then after that, right, if you're going to make that decimal a fraction, I'm sorry, not a fraction, a percent, excuse me. Move it 2 places to the right. We're talking just rounded to the nearest whole number there, 33%. So you have a 33% chance of getting an S, V, or L tile out of that group, which once again means it's unlikely for that to occur. Number 3, the probability of not a D. Okay, well, there's only one D there, and you know there are 9 total tiles here. So if it's not D, that means you have 8 out of 9 other tiles there, right? They have different letters on them. And so now let's look at that as a decimal. Do 8 divided by 9. And this is another one that's repeating. So it's 0.8 repeating. Now, if I round this to the nearest whole number, like I did for number 1 and 2, that means this is 89%. So you have an 89% chance of getting a tile that is not a D. Now, this is actually considered likely, right? So that's likely to occur if you pull any other tile here except for the D. All right, so I'm going to have you try a couple and see if you're catching on. So go to Independent Practice on page 715 and go ahead and try number 1, 2, 3, and 4. And you're using this spinner over to the right. So it says the spinner shown is spun once. Find the probability of each event. Write each answer as a fraction, percent, and decimal. So do the same thing that we've just done on the previous examples. Try that for me and pause the video. And then when you're all set, unpause and check your work. Okay, check to see how you did. So in number 1, you should have 2 8s or 1/4. The probability of landing on blue, which is 25%, and that's considered unlikely. Number 2, the probability of landing on red or yellow. Well, there's 3 of those there out of the 8, and so that's 0.375 or 37.5%. Or if you rounded it to 38%, that's fine as well, and that's also unlikely to occur. Number 3, what's the probability of that spinner not landing on brown? Well, there's no brown at all on that spinner, so it's 8 out of 8. which equals 1, which is 100% certain that you are not going to land on brown. Number 4, the probability of not green. Well, there's 3 green on there, which means there are 5 other spots on that spinner out of the 8. So that would give you 0.625 or 62.5%, which again, if you rounded that to 63%, that's fine as well. And that is likely to occur for you to not land on green. So hopefully you did well. You're catching on to this. And so I'm going to have you try again. So you're going to go to the extra practice on page 717. And here you're going to see always with the extra practice that they always do the first couple for you. So you'll see number 12 is done and number 13, which means you're going to do 14, 15, 16, 17, 18, 19, and 20. And then you're also going to come down and try 22. Try 22. So again, you're going to work these out. Now, if you want to, I'm giving you a few more problems to do here. If your crew teachers, if you're in person, are okay with you working with somebody by you or within your pod, then by all means, that's totally fine. Otherwise, on your own, and then work these through. You're going to pause, right? And then come back and check the video check the video again for the answers. You won't hear my voice again. You'll just be checking the answers on the work. And so this actually ends your lesson for today. So you will be all set for partial of learning lesson 1. We will finish up lesson 1 tomorrow on Tuesday. So if there is that extra time, you can work on Alex today. So again, pause, work these out, and then come back and check your answers. And then I will see you tomorrow. All right, I lied. I'm talking. So at this point, I'm hoping that you already did the work and now you're just checking your answers. Okay, so there they are. All right. See you Tuesday.